Here is an example regarding hypothesis testing about the parameter mu, in other words, the population mean. So to test the null hypothesis that mu is 107 versus the two-tailed or two-sided alternative hypothesis that it is not 107, the simple random sample of size n equals 35 is obtained. Does the population have to be normally distributed to test this hypothesis? No, because we have a sample size of 35, which is greater than or equal to 30. That means the central limit theorem is going to start to kick in. So even if the population's distribution, from the individual scores was not normally distributed with a sample at least as big as 30, the central limit theorem kicks in and the sampling distribution of X bar becomes normal, approximately normal. If X bar is 104 and S is 5.8, compute the test statistic. Okay, so let's get this stuff from college algebra out of the way. Your formula is X bar minus the claimed mean divided by, claimed mean was 107, divided by the standard deviation not of the sample, but divided by square root of n. S divided by square root of n. Okay, so we've got 5.8 divided by the square root of 35. That's what we learned about the sampling distribution of X bar. And they want this rounded to 2 decimal places, surprisingly. Usually that would be 3. Okay, so that's going to round to negative 3.06. Which should not be surprising in that it is negative because X bar was less than the claimed mean. So, since this is a two-tailed test, we're looking to find out if that X bar is something extreme, something unusual. Is it really low compared to the claimed mean so that it could be on the left side, but since this is two-tailed, or it could be on the right side? Approximate the p-value. Okay, so let's see here. All right, there are 34 degrees of freedom. That is one less than the sample size. And our value for t, we rounded that to negative 3.06, but table 7 is only showing positive values. So I'm going to think about 3.06. Looking in the 34 degrees of freedom row, looking for the 2 closest values that are consecutive. 3.06 is larger than the 3.002, but less than 3.348. Let's keep track of the columns we're in. That would bring us up to these two. Notice that that area or probability is smaller than that one. Also, these need to be doubled because this is only talking about the right tail, and this is a two-tailed test. So double this, 0.002, double this, 0.005. That's the first option. Interpret that. So both of those values were to three places, to the thousandth place. If we obtain 1,000 samples of size n equals 35, then okay, so multiplying those values by 1,000, 2 and 5. We're strictly in between that. So I would expect 3 or 4 samples of size n equals 35, where we'd get an X bar that extreme. Now they don't say 3 or 4. So I'll go with that one. We start off assuming innocent until proven guilty. So if mu really was 107, getting that X bar of 104 would happen with 3 or 4 samples, about 4 samples out of 1,000 such simple random samples of size n equals 35. And since our p-value was less than 0.005, which is less than 0.01, 0.005 is 5 1,000ths, whereas 0.01 is 1 100th or 10 1,000ths. 5 10,000ths is less than 10 1,000ths. Would the researcher reject the null hypothesis? Yes.